This lecture is about extending the IV estimator to something called the Generalized IV Estimator, or the GIV. So the setup is very similar to the setup of the IV estimator. That is, I have a linear regression model, I have random sampling, and I have the case where some of the explanatory variables are endogenous for one or another reason, and some of them are exogenous. The difference now is that I may actually have more than one instrument for my endogenous variables. So I have at least one, but I may actually have more than one. So a common example would be, again, the salary equation, where y is the income and one of my explanatory variables is education, and education is then assumed to be endogenous. So in this case, I may actually have information of both the level of education of the mother as well as of the father. And in that case, I have two instruments for education. For explanatory variables that are exogenous, again, we only use one instrument, and that is the variable itself. So if xj is exogenous, there will be only one instrument, zj. So in this case, the complete set of instruments will now be from z2 through zl. So I have l minus 1 instruments. I only have k minus 1 explanatory variables, so the case now is that l is greater than equal to k. If l is equal to k, that is, if I have precisely one instrument for every explanatory variable, then we will do the instrumental variable estimator as before. But when L is greater than K, we can actually apply a different estimator called the Generalized IV Estimator. Again, we need matrix algebra to really express the formula for the GIV estimator. It does look different than the IV estimator, and again, we just have to trust that they are correctly programmed into econometric software. As a matter of fact, you don't even need to tell your software whether you want to use GIV or IV. It will figure it out by itself. If the number of instruments that you use are exactly equal to the number of explanatory variables, it will use IV, and if you have more instruments than explanatory variables, it will use the generalized IV. So for example, if I go to Gretl and I add my dummy variable also, so I have the same number of instruments. Now if I click OK now, I have 4 regressors and 4 instruments. It will give me the IV estimator. I have one instrument for the the endogenous education. So let's add one more. Let's add dad ed as well. That is your father's level of education. So we add that to the list of instruments. Now I have 5 instruments and 4 regressors, and Gretl will use generalized IV to estimate this model. Both IV and generalized IV are called two-stage least squares as well. So on the right, I have the IV estimator with just one instrument for education, MOMED, and on the left I have the generalized IV estimator with 2 instruments, MOMED and DADED for education. So the thing is now that both of these will give me consistent estimates of the coefficient. But, and that's the important point, the generalized IV, the one with more instruments, tend to be more efficient. You can see that this happened in this case. For example, the standard errors has gone down in the left regression compared to the right one. And that is in generally true. The more instruments you use for an endogenous variable, in general, the more efficient your estimates will be. If you reduce the standard deviation or not by adding instruments, well, that depends on the strength of the additional instruments. To really make your estimator more efficient, you need to add good instruments. The same can be done easily in eViews. You just go to this setting again, and you again just add one more instrument to your list, dot head, and it will do generalized IV with two instruments for the endogenous variable. So here is what we can say about the generalized IV. It's also unfortunately generally biased, but the bias tends to go away as n increases, and it is consistent under mild conditions. But remember, it is consistent even when I have one instrument per endogenous variable. There is also a method of finding consistent standard errors for the GIV. We will not get into that topic in this lecture. And finally, the important point. The generalized IV estimator is in general more efficient than the IV estimator. And it's also true that in general, the more instruments you have, the more efficient your estimator will be. But unfortunately, finding good instruments in a practical setting is generally a very difficult topic, or a difficult task, I should say. But if you want to have good estimates and good inference, then it is important to try to find as many relevant instruments as possible.